In this video, we're going to find the Laplace transform of t times e to the negative t. So we're not going to be using the tables, we're going to be using definition here. So recall that the Laplace transform of f of t is the integral from 0 to infinity of e to the negative st times f of t dt. F of t will be t e to the negative t. So replace that into the equation. And here we have two e's here, and so when we're multiplying, we're going to add the exponents, and we factor out a negative. And for this, we're going to use integration by parts to solve the integral. So for now, ignore the limits here. Pretend like 0 and infinity are not there. Let's just find the antiderivative. So let u equal t, and so dv will be e to the negative s plus 1 times t dt. The derivative of t is just 1, so this will just be dt. And then we're going to do the antiderivative of dv, which is basically dividing by the derivative of the exponent in this case. And so this will just be uv minus integral v du. And this is what we get. So we have to integrate this one more time. So you divide again by the derivative of the exponent. So that's why you have the square here and the minus. And recall that this is technically going from 0 to infinity, but because it's going to infinity, we have to use a limit. So this is called an improper integral. So what I did was I replaced this with t, and I put a limit as t approaches infinity. And then I plugged in t first. So this is the part where I plug in t. And then this part I plug in 0. So this is just a fundamental theorem of calculus. The nice thing is that I'm multiplying this by 0, so this goes away. E to the 0 is just 1, so I'm left with 1 over s plus 1 squared, and then 2 negatives will make it positive. And now here I can rewrite this as just t over s plus 1 times e to the s plus 1 times t. Of course, a negative over here. Yeah, the exponential is going to beat the t here. So it's going to grow a lot, the denominator is going to grow a lot faster. So that means this thing should just go to 0. Same thing with this. And so what I'm left with is 1 over s plus 1 quantity squared as my final answer.